Hello, and thank you for joining today's Roads and Bridges webcast. Our topic this afternoon is the power of AI for predictive roadway maintenance, sponsored by Bentley Systems. I'm Ryan Curtis with Endeavor's Building and Construction Group, and before we dive into the great presentation we have in store for all of you today, let me explain how you can participate in it. If you have any technical difficulties during today's session, simply type your issue into the Ask a Question box, and a member of our team will assist you. You can also click on the question mark help button in the upper right-hand corner of the screen. We also welcome your questions during today's event. We will answer as many as possible during the Q&A session that will follow the main presentation, but please, feel free to send in your questions at any time. Once again, to do so, simply type your questions into the Ask a Question box and click on the Send button. And lastly, please be aware that today's session is being recorded and will be available on the Roads and Bridges website within the next week. You'll be notified by email when the archive is available. Now, let's meet today's speaker. Mark Pittman is the Director of Transportation AI at Bentley Systems. As the founder of Blyncsy, Mark is passionate about improving the world through technology and innovation. Prior to his current role, Mark worked in areas as diverse as political campaigns, law firms, startups, and even a Fortune 500 company. More recently, he was engaged as a consultant for wireless advanced vehicle electrification, and was the lead student director of the Lasande New Venture Development Program at the Pierre Lasande Entrepreneur Institute at the University of Utah. Now a part of the Bentley family of companies, Mark leads Blyncsy as the Director of Transportation AI. Mark, I'm excited to have you on with us today and to dive into the future of the transportation industry.
Thanks, Ryan. Pleasure to be here.
Yeah, no, thank you. So I guess let's start with this. What role does technology play in delivering transportation infrastructure projects today?
Yeah, I mean, what a compelling question. I think the quick answer is no transportation project gets completed today without the role of technology in some way, shape, or form. You know, and the origins of Bentley Systems, I think, are a really good starting point. Bentley's core technology is designing and engineering the roadway surfaces, the bridges, the tunnels, the sewer lines, the water mains, the energy system. All of that critical infrastructure is designed using a Bentley tool. That's kind of the origin, the DNA of the business. At Blyncsy, we're using technology to leverage this in an entirely new way. And that's understanding the condition of our roadways to identify where maintenance needs to be, where roads need to be built, what kind of needs we have out there. And it's not just the power of the technologies we're delivering. It's not just AI. It's not some new application. We've gone from physical paper design documents to a digital design environment over the last 25, 30 years. And now we're accelerating into an entirely new future. It's really exciting. We're looking to understand what that looks like. But the core of it all is technology, because we need to augment humans as much as possible. There are fewer PEs than ever before in the transportation industry. There's more work than ever done before. And more importantly, there are fewer government employees than ever before doing that work. So technology allows them to augment themselves, become more productive, and get more done faster.
Okay. Well, then let me ask you this. Do you have a specific example of a time where you saw technology make a significant difference in the success or efficiency of a transportation project?
Yeah, absolutely. Well, it's kind of the core of what we do every day. Our technology at Blyncsy uses crowdsourced dashcam imagery from the vehicles driving on the roads every day in near real time. We use AI to analyze those images. The cost of our technology is 85% of the cost of an in-field inspection done by a human. But the delivery timeline is a fraction of that, right? Sending someone out to go drive 1,000 miles of road is going to take them hours to do. They've got to collect that data. They've got to aggregate that data, put it in a spreadsheet, draw a sense from it. Our technology is working in perpetual near real time and aggregating this. So it's a function of two things, right? It's a function of the cost, of course. The agencies have got to be as cost effective as possible. It's really interesting for us to understand the economic side of this business. But conversely, it's about the ability to get things done, right? We would all be very frustrated in our day-to-day if we wanted to watch a show on Netflix, for example, and we had to say, okay, we want to watch a show on Netflix. We've got to go drive somewhere, get that video, come back again and plug it in, right? Back to the good old days of DVDs and Redbox. We don't live in that world anymore. But in some ways, our government customers still do from a data collection perspective. And we're looking to streamline that entire application. So really the power of AI allows us to analyze this in near real time. The power of dash cam imagery allows us to collect data perpetually on all of the roadways. And what's really interesting about that is we are seeing the roadways from the perspective of the human drivers. From the perspective of those road users who the roads are being built and designed for, we're seeing what the roads look like. Now, a government agency for the first time has the capability to, in near real time, understand when conditions change on the roadways from the perspective of the driver and how that might impact their ability to use that infrastructure. That is a critical and fundamental change in how we operate.
So how do you ensure that today's technology is scalable and adaptable for the future?
Yeah, it's a really, really good question, Ryan. I think we're big proponents of open data standards at Bentley Systems. We recently acquired a company called Cesium, a leader in the open mapping space. What's really interesting about the Cesium acquisition that Bentley did is that Blyncsy was built on Cesium. We would not be here today. I would not start this company had the Cesium tools not existed that allowed us to do this. So it's kind of a part of our ethos, really, to be in this open data standards part. One thing that's really critical for agencies to think about as they look at this world is the data needs to come from somewhere and needs to go somewhere. And the place it comes from and the place it goes will probably change over time. But you want your data to be scalable and forward-looking. Let me give you an example. Today, you may use an asset maintenance management software of some kind, or you may not. Maybe you use spreadsheets. Maybe you're using Esri, maybe you're using Bentley's iTwin, a variety of geospatial mapping tools. Those tools will probably look very different in the next 3 to 5 years. You may not even have the same tools anymore. You may have new tools. The data sets that you collect today need to be interoperable with as many of those systems as possible, and they need to be forward-looking. So at Blyncsy, when we collect imagery, let's say we collect dash cam imagery on your roadways, and we're looking for a sign analysis. We're collecting signs on your roadway. We're understanding which MUTCD sign codes you have. We're assessing the condition of those signs, and we're providing that data back to you. In 3 years, Blyncsy may come up with a new model that looks at the sign and says, what's the pixelation of the image when a vehicle drives into the sun at a certain angle at a certain time? And that same imagery should be forward compatible and backward compatible with those new models, right? And that's how we've designed and architected this system. I think it's a really core and critical part of Bentley's ethos and our value proposition to the market, is that we know we are at the fundamental, crucial intersection of transportation technology. We know that at the end of the day, it starts with what happens on the ground. From designing the road first to managing and maintaining those roadways, that's kind of critical. And that's where we see that intersection becoming really important.
Okay. So switching gears a little bit, what do you think the issues are that transportation leaders are facing? And how do you think technology can help the owners and operators alleviate some of their problems?
Yeah, it's a really good question. I spend a lot of time on the road, over 100 days a year across the last several years. I spend a lot of time with the agencies in the field. And the biggest thing I hear is workforce. There aren't enough of us, whether on the private sector side of the consulting firms or within the agencies themselves. There are fewer people than ever before. And how do we do the amount of work that we've got with the limited staff that we've got? So that's kind of question number one and issue number one. And so really what that comes down to for me is workforce augmentation through technology. When I say augmentation, I want to equip this human with the tools, right? Picture a human working in manufacturing who, generally is like lifting heavy loads. Providing that person a crane, providing that person a mechanical suit that allows them to lift things faster, easier, simpler, without less strain on their bodies, augmenting them. Technology provides that capacity to our government agencies on the transportation side. So let's take our infield collection inspection example again. Let's say you have 1,000 miles of road and you're looking to comply with the new federal government's 2026 minimum visibility rules for pavement markings. You have two options. You can hire a firm for $200 to $400 a mile to go drive those roadways and collect data for you. You can go out by hand and collect that data with a spreadsheet. You've got to go out at nighttime conditions. You've got to have two people in a car. You've got to be driving around in a vehicle, which means you're engaging in the cost of those humans, the cost of the vehicle, the cost of the fuel, the wear and tear. And those humans could be doing other work during that period of time. So how do we allow agencies to use technology to bring them the right tools in the right place at the right time to augment their work, right? Imagine if all that data came into your inbox, was available for you, and then you made decisions. think about this as the application for technology and for AI in particular is making life as easy and simple as possible for our public servants who are overworked and understaffed already.
Okay, perfect. So, how are transportation leaders balancing the needs for innovation with the operational realities of, tight budgets and limited resources?
Yeah, absolutely. That's a really, really critical question. I'm a firm believer that everything that happens within the agency that's going to get traction has to solve an operational need. Um, Sometimes we have pie in the sky ideas that come out from leadership or from the federal government, for example, that never really get implemented or fully turned into reality because they don't solve a problem for the day-to-day operators on the ground. So that's the critical piece, in my opinion, what we've seen being done really effectively from an innovation perspective. And we're proud to be headquartered in Salt Lake City, and we work closely with Utah Department of Transportation, which for years has been a leader in innovation in the space. I think one thing that the team at Utah has done exceptionally well is they've always tied back their innovation to a specific pain point and problem set within the organization. How do we make someone's life easier? And if that person doesn't adopt the technology, then we know we've done something wrong. So I think that's the easiest way to think about this from a metrics perspective. The other thing is, it doesn't always mean that technology will save you money in the short term. It might save you money in the long term, right? It might cost you more money to collect data up front, but that data will make it much cheaper for you in the long term. It will reduce the burden on our government employees to collect that data or do that data. But the other really kind of critical element here is we don't know what's coming next, right? We don't know what the future looks like. We don't know what we're going to need. And so being as equipped as possible is really crucial. And this is where that kind of forward and backward looking compatibility really matters. We want to make sure that all of our government agencies can get access to the data they need at the right time. They're not dealing with data silos. There's no data privacy issues around this, and the data can be in the right place at the right time. So my ethos has always been the open AI mentality is that the data can live in many tools. Maybe your traffic safety folks use a different software than your traffic operations team and your maintenance team, but the data should be universally applicable to them. So we don't even sell a user license by seats. We sell an agency-wise enterprise license. So the consultants that work for you, any member of your staff can collect and use our data in a myriad of different ways. We don't know what those ways are today, and those are constantly changing. So we're really working to understand what that will look like.
Okay, cool. So let me ask you this. How does your platform and technology work? I know you talk about crowdsourcing camera imagery, and how does that happen, and how is the data processed?
Yeah, it's a great question, Ryan. And maybe what we'll do here is kind of veer to one of the slides just to kind of give everyone a visual representation of what this technology looks like. What's really cool about our ability to make sense of the roadways is the way and perspective in which we see this data. So at Blyncsy, the fundamental basis of our technology is that we collect imagery from dash cams. These are vehicles that are driving around doing their day job. Semi-trucks, delivery vehicles, that vehicle dropping off that brown box in your front door every day, they're all equipped with cameras. And they're equipped with these cameras for their own business purposes, which is a really key variable. These cameras are in the vehicles to make sure that the driver isn't drunk behind the wheel, to make sure they're stopping after 8 hours to comply with federal motor carriers laws, to looking for insurance purposes and other applications. So there's a business reason this camera exists. And this camera is connected to the cellular network. And these guys have a really big Verizon bill, right? And so we went to these dash cam providers and we said, hey, how can we purchase some of that imagery from you, subsidize the Verizon bill that you've got, use that imagery to help our government agencies understand what's going on in their roadway. The really fundamental piece here is we are seeing the roadway through a camera lens. And we're seeing the roadway the way grandma does in a Buick or Elon would in a Tesla, from the perspective of a driver driving down the road. And this is the really fundamental and kind of key part of this technology is over 1 million vehicles are equipped with these dash cams, constantly driving around the roadway network, constantly collecting that data, and it allows us to make sense of things in a variety of ways. So we're detecting pixel by pixel objects within an image. This could be potholes or pavement markings. It could be degradation of crosswalks. It could be the presence of work zones, a variety of other things. So as you drive down the roadway, your human brain is making sense of this. Think of your eye as the dash cam, right? And your brain as the computer server, the Blyncsy, making sense of the roadway infrastructure as it drives. This is happening in perpetual near real time at a fraction of the cost of sending someone out to the field. Why? Because the vehicles on the roadways are already collecting the data. This future that we've been told is coming at us, where cars will talk to infrastructure and infrastructure will talk to cars, it's already here. It already exists. And the humble dash cam, I like to say, is the peanut butter and jelly gluing the two halves of the sandwich together, right? It's bringing the image to the forefront. It's allowing us to apply the AI and algorithms to the forefront, and then it's allowing the agency to ingest and make sense of it. The beautiful part here is we're extracting and selling the agency insights, not a bunch of images. So not flooded with a bunch of imagery that's useless to them, not subject to a bunch of public records issues with all these images. They're getting an extraction of the thing they care about from this image specifically. The location of a sign, the damage on the roadway, the guardrail that's defective. So they know how to roll a truck and where to go before they put someone in harm's way for no reason. That's the core of what we're building.
Awesome. So how accurate is this method of data collection compared to how agencies are doing it now? And about how long does it take to collect and process this data?
Totally. Yeah. So there's a couple really interesting ones for us here. The first application from a accuracy perspective is the state of Utah engaged with the University of Utah on a project to compare LiDAR to photogrammetry, the technology we're talking about here, to compare the differences for a roadway asset inspection. They found almost a perfect correlation between the two, I think over 98% correlation and accuracy between the two technologies. There were even use cases in which the imagery-based technology performed better than LiDAR. Why? Because imagery can see the sign and make sense of what's on the sign. LiDAR is identifying the presence of a sign. It's much harder to make out what kind of sign that might be. So, as we take this technology to the market across the entire country, from New York to Hawaii and everywhere in between, we've used this technology on a variety of state-level applications and city-based applications. So we allow our customers to make sense of this, right? We extract what's going on in the image. We let them see the image. They know what's going on and where to be. And we do this at a fraction of the cost, right? $8 per center line mile to collect the imagery. It is a fundamental new way to make sense of roadway from an intelligence perspective.
Okay, awesome. So there's a lot of talk about artificial intelligence in general. And there's still quite a bit of confusion about implementing AI, a little wariness about it. How will it impact, wariness about implementing AI and how it will impact any given industry. In this use case, how does AI benefit a transportation agency?
Mm-hmm. Yeah, it's a really good question, Ryan. So, two things to start with. One is there's two different broad categories of AI, and we'll step back about 60 years and we'll think about AI from a very fundamental perspective. AI, artificial intelligence, is really computer-led insights that drive some kind of value for a human, right? We've historically called this machine learning. And now all of that's gotten wrapped up into this catch-all term called AI. So one, you got to be a little careful about what folks are trying to sell you, because it's not all AI, right? You're trying to understand what it is that you're doing and where it is. So step one is, am I even dealing with AI, or am I dealing with machine vision or machine learning or applications thereof? Some of our work is machine vision based, some of our work is machine learning based, and some of our work is AI based, right? Really crucial distinctions. The two types of AI broadly are generative AI, which is what you're seeing in the news and which is very controversial. That's the ability to ask a computer to make a picture, right? And we've seen this being used for political purposes and all sorts of other issues that are popping up closely. We use AI in a generative way to generate intelligence on our roadways that we use to build into our models. We can use our generative AI capabilities in some of our large cloud computing partnerships to create 1,000 examples of a sign in a certain event. So let's say, for example, that I wanted to see a stop sign in Hawaii on the edge of a cliff at 2 p.m. with the sun shining during the rain. And I wanted 1,000 examples of that. It would be really hard for me to collect enough examples on the ground to drive that value. A generative AI allows me to ask a computer to make a bunch of images like that. Different angles, different perspectives, different locations, different places. Using real world data, it can manipulate and create synthetic representations of that. We can use that to train our AI to detect those sorts of things. This is what a stop sign looks like at 2 p.m. with sun behind it in the rain in Hawaii, right? For example. So those are the types of ways that we think of this. And we use this, and it's a very important application for some of the models that we build, specifically things like retroreflectivity, where we're identifying how much light is coming back off of an object, right? So retroreflectometers, generally, you go out during the daytime conditions, you hold a device up to a sign, for example, you measure how much light is being bounced back off an object. our technology does the same thing using dash cams. The camera knows the exposure that it has, that the lens has. It knows how much sun is in the background. It's how bright the object is, the headlights, all everything around it. And then we can see how many lumens of light effectively are being reflected back into the camera lens and use this. Generative AI and AI technologies were a really core part of doing that. So as an agency looks at AI, they've got to ask one of two questions. First is, what is the data that's being used to train these AIs up? If it's a black box and no one knows, then you probably have some issues, some questions, right? You need to really fundamentally understand where the data is coming from. In our use cases, these are all publicly available images. This is all collected from the public domain, no expectation of privacy. It's all happening on our public streets. All of our images are de-identified, license plates, faces, even reflections of faces are all blurred. And we use this technology to understand things about street level assets and street furniture. These are public assets, so really safe things to analyze and look at from an AI perspective. If you're looking to apply this in a more human focused way, you've got to be a lot more cautious about what you're thinking to do. But the fundamental level from an AI capability and thought process perspective, the way to look at this is, what data goes in and what data goes out and what decisions are being made in the in-between. If it's a black box and no one can tell you what the decision-making process is, you might have an issue. And that's a really fundamental difference that we have in our capabilities. In transportation, we have the MUTCD, right? We have federal standards that tell us what things should look like. We have some differences state to state and city to city in how people want to interpret that. Should I paint a crosswalk when its visibility is 50 millicandelas versus 30 millicandelas? Those sorts of questions. But fundamentally, we have organizational structure across the nation that allows us to make sense of these things regionally and nationally, and allows us to further those best practices by using AI.
Okay. So for an agency that might be looking at improving their maintenance and operations activities using technology like this, what's the biggest barrier you see that's preventing them from doing it now? And what are the biggest benefits once they do start using it?
Yeah, great question, Ryan. So I think from a barriers perspective, everyone's incredibly busy every day. And we're used to vendors showing up and hounding us and saying, hey, I got something to sell you. Hey, I got something to sell you. I like to think that we go into a lot of demos when people walk out of the meeting and say, this was a worthwhile meeting that I had today, right? And that's not something you hear all the time. We know our public agencies are being inundated with these sorts of presentations, but you've really just got to take a chance and take the application to use this. So we offer free pilots and free demonstrations of our technology. In fact, we published on the Blinksy website under the Explore Maps icon a public map of all 50 states, a small, medium, and large city in all 50 states, our top 10 most popular detections, and just put them on the website. No salesperson needed to do a demo and test out Blinksy technology yourself. You can go to my website and play with the maps yourself. It's a perfect replication of what you're going to get from our perspective. So I think that's step one is we just don't have capacity, right? Time, and oftentimes there's a wariness to engage with new technologies. We've done things a certain way for a long time. We got plenty of things to do. How much time and energy do you want to waste on doing something differently? Implementing that technology, working with the IT department, working with the streets department, working with transportation, talking to leadership, maybe presenting to city council. There's just a lot of work that needs to go on. Once the technology is in the door, though, I think there's a really incredible story, one to be told from the city and the local county's perspective in particular. How do you improve the level of service, right? All politics are local at the end of the day. And people understand nothing more than the presence of a stop sign that was there yesterday, that's gone today, that threatens their neighborhood, than work zones and barrels that might be on the road blocking their way to work, than a pothole that they hit when they're trying to go to the grocery store. Those sorts of things are very practical. Think of this as your eyes on the road perpetually all the time, looking for issues and reporting them back to you in a harmonious and equitable way, looking at your entire city regionally, not just the squeaky wheel, right? The wealthy enclave that calls all the time and there's a slightest inconvenience on their road, but also looking at your regional transportation network collectively and saying, okay, I've got a bunch of roadway miles. I'm inspecting my pavement condition maybe every 5 years. It's probably not enough with all the EVs on the road and all the trucks and trailers on the road now. How do I do that in a cheap and effective way? How do I understand if my pavement's changing faster than I anticipated, right? We've got changes in climate and temperature impacting our roadways now too, extreme weather events. All these things are starting to compound. And for a fraction of the cost, you can understand your roadways every single month over 5 years for cheaper than you might do one big LiDAR inventory on your roadways. And that's the incredible power and scale of AI in the roadway application.
Okay. So you mentioned autonomous vehicles. How does this technology work to help these vehicles? And What are maybe some of the bigger implications of using crowdsourced imagery and AI?
Yeah, great question. So let's start very fundamentally. If a autonomous vehicle, whether a vehicle using an ADAS system and an automated driver assistance system that you might buy in pretty much every new model of car today, right? Lane assist technology, or it's a Tesla driving an autopilot, a Waymo, a Cruise, it doesn't matter. If they can't see the paint lines, they don't know where to go. If a human can't see the paint lines, they don't know where to go. 50% of our roadway fatalities are due to roadway departures. Paint on the ground is the single most important variable here. This is largely why the new MUTCD update was put in for minimum paint line visibility. The rule explicitly calls out the use of autonomous driving systems or driver assisted systems. We want to detect and see where this is. The state of Connecticut just released a really important study over the weekend where they found almost no correlation with retroreflectivity and the ability of an ADAS technology to see the pavement markings. That's a huge revelation if that's true and that's validated, but it's really true for two different purposes. We've for a long time maintained very publicly written articles and published about this, that the way we see the roadways during the daytime and nighttime are very different. And a computer sees the roadways differently than we do as humans. A computer has the ability to do image enhancement, to see an image nighttime much crisper and cleaner than we as humans do. And that's why retroreflectivity was always very important for human drivers to drive at night. Autonomous vehicles, ADAS systems don't require that same level of retroreflectivity. So as the fleet starts to migrate, as ADAS becomes very prominent, the question also becomes, what do we still need? Rumble strips, in my opinion, will phase out. Why? Because autonomous vehicles don't feel rumble strips. What they see is edge lines. Crisper, cleaner edge lines are a fraction of the cost of putting in rumble strips. Over time, we'll start to see these sorts of changes in the network. But at the end of the day, there's three primary things you need to think about from an autonomous vehicle perspective on your roadways. The paint lines need to be clear and they need to be visible. The presence of work zones and traffic control devices needs to be made public, ideally through the work zone data exchange, the WZDX data feed that the federal government has put up. It's a public, open data feed. Anyone can contribute their work zones to it. And Google Maps, Apple Maps, autonomous vehicle providers, you name it, can pull that data down free of charge and integrate it into their navigation system. The last one is signs that are safety critical. Stop signs, yield signs, particularly exit signs, are really important for these vehicles. They're using them to make decisions in near real time, just like a human would. So if you focus on those three fundamental pieces, you at a city, county, state level can already accelerate autonomous vehicle deployments on your roadway network.
Okay. In the webinar title, it mentions predictive road maintenance. So how does your technology allow agencies to begin to predict what issues need to be addressed instead of reacting after the fact? And what does this mean for a city or state DOT?
Absolutely. Great question. So let's go back to the pavement, right? The pavement is the single most valuable asset that we own in America. The size and scale of the sheer pavement surfaces in the country, the cost to maintain those and update those, it's an incredibly valuable data set for us. And a couple of really fundamental things happen. The agencies that live in cold environments that have a freeze-thaw cycle, right? Where it's snowing in the winter, where you've got snowplows, know this all too well. A small crack that I can fix very simply with the seal is very inexpensive. If that crack turns into a pothole and that pothole grows and it then all of a sudden degrades my road base, that's become a multi-$1,000 repair. How do we identify things like cracking? How do we help you understand your pavement management plan in a simpler way? How do we identify cracks as they're evolving month to month, not 5 years over 5 years? So you don't have to worry as much about pothole palooza when the snow or the heavy rains hit. And instead, you can use your pavement management plan to apply the right seal at the right time to reduce the costs to treat those roads and extend the useful life of those assets. At the end of the day, the two ends of the political spectrum converge on these data points. You're both saving money if you apply the right treatment to the right time, and you're reducing the amount of material that you need, right? Contributing both to environmental savings and cost savings. We are all after the same fundamental thing, keeping our roadways in a good state of repair as long as humanly possible at the lowest cost. That's what we're after.
Okay, perfect. So when people step back and look at all this in the context of building and maintaining safer roads for everyone, from the motorist to the autonomous vehicle to the pedestrian or cyclist, what does it all mean? Where does Blyncsy fit in? And what changes are you trying to affect?
Yeah, big question. So, fundamentally, I'm an entrepreneur, and I started this company 10 years ago with the vision and idea of making our transportation system smarter, safer, and more efficient by using cloud computing and crowdsourced technologies. At the end of the day, what we're really looking at is to get people from where they're starting their day to where they want to be, right? We're all engaged in the same system of transportation. The transportation network is crucial to our way of life. You can't get your groceries, take your kids to school, go to work without the transportation network. We all take it for granted every day. And I've become incredibly passionate about supporting our transportation network at large. At the end of the day, for us, it's not a function of how you're using your roads. It's about helping you manage your roads in the best way. If you have bikes on those roadways, if you've got scooters, if you've got humans, if you've got cars, if you've got buses, these are all different modes of transit. Transportation to wherever you're going. We want to help you make sense of that. Our technology does pedestrian and bike counting. It identifies the presence of pavement markings in your bike lanes. It can help you assess the condition of your bus shelters. If there's roadway debris or trash overflowing the trash cans of the bus shelters, if the streetlights are out at night, if there's graffiti on the bus shelter, things that might make someone feel unsafe. It also helps you understand the physical pavement itself, right? The roadways at their best. Potholes, cracking, pavement markings, curb and gutter, sidewalks. Those are the nitty gritty, the physical infrastructure parts, the pieces that allow us to go through our way of life. And whether we're supporting bicyclists in the bike lane, humans on the sidewalk, or cars on the roadway, all of them fundamentally come down to helping someone get from point A to point B in the safest and most efficient way possible. That's what we're building.
Perfect. Well, Mark, thank you so much for your fascinating insights. I think now is a good time for us to transition to some questions. Now, a few of you have already submitted questions, so we're going to jump right in. And once again, if you'd like to submit a question, simply type your question into the Ask a Question box and hit the send button. So the first question is there any pilot project yet? And if yes, what about the cost per mile?
Yeah, absolutely. We've done a variety of pilot projects across the country and now the world as we start to go global this year. Feel free to visit blinksy.com, BLYNCSY.com for a variety of case studies, including a large project with the city of Fort Worth, Texas, Plano, Texas, projects in Hawaii, Alaska, and across the country. From both the local and regional perspective forward, we've done work across the globe. And we're looking to deploy this technology in a very inexpensive way. So our fundamental cost structure is very simple. We started at $8 per centerline mile to collect imagery and 25 cents per mile to inspect that roadway for a certain asset class. So $8 to collect the imagery, 25 cents for pavement condition assessment, 25 cents for streetlight detection, 25 cents for sign inventory, 25 cents for paint line visibility. And this allows you to add and subtract wherever you want to. You might inspect your arterials once a week. You might inspect your entire city once a quarter. You can pick and choose where and when you're at and how to apply that technology in a scalable, cost-effective way.
Awesome. Next question is it possible to get the image data also, or only just the resultant data?
Yeah, it's a very good question. So every time we deliver an insight to you, you will see our image. You'll click on a link. So imagine that you're in Bentley iTwin or you're in your Esri instance and you click on a dot on the map. You're looking at a sign that Blinksy detected to you. We told you the MUTCD sign code and the condition of that sign. And when you click on the button, you'll see a pop-up image, a web browser link to that image. This is really important. You can see that image and use that image, but it's not on your servers, not on your local machine, not subjecting you to public records requests.
Awesome. And can this currently score sign retro reflectivity or only pavement markings?
Yeah, it's a great question. Retroreflectivity is applicable to both our pavement markings and our sign application. It requires both the daytime analysis and a nighttime analysis of those roadways. We're collecting nighttime imagery, seeing what the presence of the sign is, and identifying how much light we're getting back from those signs as they drive down the roads. That's an application that we've done before, and happy to showcase that to you.
Awesome. And can Blinksy identify issues with sidewalks as well?
Yeah, our perspective is limited to what we see on the road. So if there are cars parked along the entire curb, for example, and we can't see the sidewalk, it won't be possible for us to analyze it. But in some of these instances, some of these examples and the pictures you've seen here, the sidewalk runs and abuts right along the roadway side. Those are easy examples for us to see that. We want this technology to be as universally applicable as possible, right? And so we've tried to focus on what we can see and automating those applications. So we do both presence of curb and gutter and sidewalk, and of course, some condition assessment as well.
Perfect. Well, I'm afraid we've run out of time. So for those questions we didn't have time to answer, we'll be getting back to you via email. And that concludes today's webcast. On behalf of Roads and Bridges, I'd like to thank Mark for taking the time to share his expertise with us, Bentley Systems for sponsoring today's event, and of course, all of you for joining. Have a great rest of the day.